Hello everyone, welcome to this tutorial on test-driven development. So in this tutorial I will present the theory of test-driven development, like principles and benefits, and then we will see a live Java application demo built from scratch using TDD. So first, what is TDD? It is a development strategy where the tests drive the development. It is a series of short test code cycles. So we write some tests and then write code to pass it, and then keep on switching between test and code. So what are the goals and laws of test-driven development? So the goal of a test is it should fail if the code it is testing fails the scenario that it is testing. So this means that the purpose of a test is to fail if the code that it is testing does not work. That means we know that a test works if it fails when it's supposed to. The next goal of a test is a test suite should expose as many bugs as possible. So we want to cover as much of the code as possible when writing our tests. So the three laws of test-driven development: you are not allowed to write any production code unless it is to make a failing unit test pass. So we have to first make a unit test fail and then write the code to make it pass. Why is it necessary to make it fail first? Because we know that the test works if it fails when the code is not yet implemented or the code has a bug. So we need to see the test fail to make sure that the test works. So that's why we need to write the test first and see that it's failing, and then write the code to make it pass. Next is we are not allowed to write any more of a unit test than is sufficient to fail. So this means that we can only write a short unit test, and then once that test fails, we have to write code to make it pass. Because if we write a long list of tests and all of them fail, and then we bulk write the code, we don't know whether each of them fails on the scenario that they are testing. Because again, remember, the goal of a test is it should fail if the code it is testing fails. So to make sure that a single unit test is correct and it fails when it's supposed to fail, we should only write that unit test and then write the code to make it pass before writing the next unit test. The third law is you are not allowed to write any more production code than is sufficient to pass the one failing unit test. So we have to write the simplest code that can make the unit test pass. So this is because we need to make sure that our test should cover as much bugs as possible. So if we write the simplest code that makes the test pass and then we still think that it's a bug or it's not enough, then we have to write more tests to expose that bug. So we can only write code to make the test pass and not any more code. This is to ensure that all our code will have tests. Next, let's take a look at some of the benefits of unit tests and test-driven development. So first, it serves as a documentation of all the use cases and scenarios that the code covers. So if you check out some code and you want to know what this code does and what it doesn't, what scenarios it covers and what it doesn't, if the team is following strict TDD, you can just open up the unit tests and see what scenarios the code covers. It makes sure that your code is unit testable, because since you're writing your unit test first, you try to make your components simple and isolated. You put interfaces in between the dependencies. So this in turn automatically gives you a good design, a good decoupled design. So it makes your design clean as well. Next, it enables fearless refactoring. So if you want to refactor your code, you can do it fearlessly because you have unit tests to verify whether everything still works. So you can easily refactor the code without any fear. And then it allows anyone to easily understand the code. So if someone checks out the production code and then he's concerned or he's wondering what this particular portion of the code does, all he has to do is put in an obvious bug in that portion or change the code and then run the tests. So the failing test will tell him what that code is about, what scenario, what use case the code is for. Next, TDD gives you zero debugging time, and no, this is not an exaggeration. So personally, I've practiced TDD and I've really experienced this zero debugging time. The reason is simple because since we only have one failing unit test at a time, 1 minute ago everything was working. So if a unit test fails, you know that it is because of the code you just wrote to make that single unit test pass. But since the unit tests don't pass, you know that the bug is in that new code that you wrote, which is just a little bit. So you don't have to go finding for the bug. You almost always exactly know where it is. And as a result of this zero debugging time, we get faster development time even though we write more code. So we're writing more code, we're writing tests, and we're writing production code. But our development time is faster because we don't spend time debugging. The thing with debugging is there's a lot of brain power involved. So when we debug, we think that time is passing very fast. If you try to time yourself with TDD and without TDD, you'll find that you finished faster with TDD. So those are all the benefits of unit tests and TDD. Next, we will try a live Java application from scratch using TDD and see how we can apply all these in building an actual application. So let's start with an empty Java project called TDD Demo. In this project, we're going to make a simple application that asks the user whether they want to choose a square or a circle, and then depending on what type they choose, they enter either the side or the radius, and then the application computes the area and perimeter of the square and circle, or circle, depending on what the user chose. So let's get started. First, we're going to write the square class. So we have to start with a unit test because we're not allowed to write any production code without a failing unit test. So we will have, the idea is we have an interface called shape, and then we have in the shape interface there's area and perimeter, and then the subclasses square and circle override those methods. So let's start with the test for the square class. So the first thing we want to test is whether a square should be a shape, right? So square new instance should be shape. So if we say square equals new square and give it a dimension of 5, it should be true that square is an instance test. Now it fails because we don't have a square class. So we have to create the square class first. I'm going to do that here. Create a class called square. Go back here. This code passes, so we need to have a constructor. So this is our side. So we're not allowed to write any code because we have to make our unit test fail. So our unit test is still failing because we don't have a shape. So we need to make a new interface called shape. So this is how we do TDD. Now, once there are no more compiler errors, so we still have a compiler error. Now we run this test because we want to see it fail. So to make this pass, we need to make our square class implement the shape interface. So now if we run this test, it passes because we now know that this will fail if our square does not implement shape. So now that our unit test passed, we have to write another unit test because we're not allowed to write any more production code. So next we will say square with side 5 should return area 25. So now it's going to complain that we don't have get area in shape. So we click this, it creates let's make double get area in shape, and then it will want our square to implement those methods. So since this is a double value, we need to put a delta. Like how we want it to be correct to 2 decimal places, so I use something like this. So now let's see if our unit test passes. It fails, so we know that this test works. So now we have to make it pass. The best way, the simplest code to make it pass is to return 25, right? That's the simplest code to make this test pass. So we run it and we see it passes. So we know that there is an obvious bug here, but our test doesn't know that, and we want to make sure that our test exposes as many bugs as possible. So we write the simplest code to make it pass, and then we write another test to expose that bug. So this is what we call test driven, because our test is driving our development, and we don't develop unless our test tells us to. So let's have another site, and then if we run the test, we see that it fails. So now we have to go and fix this. So how can we fix it? So now we need to introduce our variable called side, and then when it passes in, we need to save it, and then here we need to return side times side. So now if we run the test, it passes. That's cool. So now we want to see that if we pass in a side that is less than 0, it should throw an exception. So side 0 should throw, we want it to throw an exception. So we can do that is expected. So we want to make sure that if we create a square with side 0, we get an illegal argument exception. So if we run this test, it fails because we didn't get an exception. So the simplest code to make it pass if side is equal to 0, then throw new, right? So let's see if it passes. So it passes, but how about if we have a negative side? So let's copy this code and let's put negative side. So if we have like -1, it should throw an exception. Let's see if it passes. It doesn't. So what I'm gonna do is I'm gonna put like or size equals -1. So now all tests pass, and then let's expose another one. So let's put like -50. Same scenario, and then we see that our test fails. So now let's put in like size, if size less than 1. So this should pass. Okay, and next we want to follow the same approach and test for perimeter. So I'm going to copy this first test in perimeter. So we don't have yet perimeter in shape, so let's add that. Implement it here. Run the test to make it see it fail. So it fails, and the simplest way to make it pass, as you would guess, is to return 4. If we run it, it passes. So next we want to try another. So if we run this test, it fails. So the correct way is to put 4 times side, and then if we run it, all tests pass. So now we are pretty confident that our square class works. In this case, it's like a simple class, right? It seems that we did a lot of effort to write the test, but as I mentioned all the benefits of test-driven development earlier, you get all those benefits, and not all your classes are going to be this simple. So I advise you to try it. Test-driven development will really improve your the and quality of your code. So now that we have the square test, let's move on to the circle. Next, we will create a circle test class. Our first test would be the same as the square. So our new instance should be a shape. And then we don't have a circle class yet, so we need to create a new class here called circle. Check the test fails because we don't have a constructor. And let's call this radius. So that should be, so if we run this test, it fails. So we need to make circle implement shape. And now if we run the test, it should pass. The next test, let's test the get area behavior. So radius 5 should return the correct area. Now if we run this test, it fails. So the simplest fix is to return 78.54. And then run the test again, it should pass. The next test is to test another radius 6. It should return this area. If I run it, it should fail. So now we type in the area formula. This is math.pi times radius times radius. And of course we need a variable radius. So now if we run this test, it should pass. In a similar manner, we test the exception cases. So I'm just going to forward the video. We did for square, we added these two test cases, which made us add this code eventually. And if I run the tests, they all pass. Next, we'll test the perimeter of the circle, which is also the circumference. This is the perimeter of or circumference of a circle with radius 1. If you run it, it should fail. And then, of course, the simplest fix is to do this. And then it passes. And then we add another test to expose the bug. So now we need to add a real formula in, which is 2 times pi times radius. So now if we run the tests, they pass. So now we are confident that our circle class also works. Next thing we will do is to create a shape factory. So again, as usual, we need to create a test case first. So factories are usually singletons. So get circle should return circle. Have some compile errors, so we need to create the shape factory first. And then I'm just going to implement singleton using enum. Basic structure. Now if we run this test, it fails. So we should add a the simplest thing to do is return new circle file, right? But we need the dimension from the user, so we add the dimension and pass that here. So let's say 5, right? It should pass. Now the next thing is square. So if we run it, it's gonna fail. And now we need to have our checking here. So if shape string dot equals, so now if we run this test, it has to be a square. If we run this test, it passes. Now let's test for invalid inputs. We want that if the input is invalid, we want it to return null. So, or throw an illegal argument exception. So if we run this test, it's going to fail. We didn't get. So here we need to check if shape string is actually a square. Otherwise we return null. Oh no, we throw. And now let's check for if, invalid dimension. So let's say if it's a square but it's like -10, so that also should throw. So this should get invalid square. This test, it should still pass because our square throws invalid argument exception. So let's say get invalid. This is square dimension. This is circle dimension. So this should still pass because our new square, if it's invalid, we already tested that it throws an exception. And then next we want to test the lowercase square. So lowercase square should still give us, it fails. So we have to change this to equals ignore case. And now if you run the test, it passes. And similarly for circle, if we run it, it fails. So we need to change this also to equals ignore case. And then we run it, it passes, we're happy. I'll quickly write the main program so that we can see it running. We've written the application. We ask the user to input a shape and a dimension, and then we use the factory to get that shape and print out the area and perimeter. So we've already tested all these things, so we should be confident that our application works. So let's say we want a circle of radius 5, so we see the area and perimeter. And then let's say we want a square of side 80, so we have the area and perimeter. And let's input like some invalid shape like triangle. So it's triangle and 4. It's invalid input because we don't have triangle. So this was how to make an application using TDD. As you can see, we didn't spend any time debugging. It might have taken a longer for this simple application, but for complex applications, it's really going to save you time. In this tutorial, I was also talking while explaining all the concepts, so it might seem that it takes longer, but you should really try TDD, and it's really helpful to make your applications bug-free and to save time on debugging. So I hope you enjoyed this video and that you would practice TDD in order to make our software systems of higher quality and more reliable. Thanks.